All right, hello everyone. It's February 28th. Guess it's like 6 minutes away from 29th. All right, first of all, this problem, it didn't work yesterday only because I forgot to sort it. Yeah, I realized it. I did not sort. So we just need to sort it. And probably will be good if after we sort it. So how are we going to sort? We are going to sort somewhere here. So what we can do is we call it sorted nums. Okay. Then we can say for n1, n2 in zip nums1 and nums2. We're gonna do it with n2 and 1. Right, so I can sort this easily. So after sort, we're gonna do this. No, these are not, and this should be sorted nums. Okay, so this should be sorted nums. Sorted nums 0, 1, 0, 0, right? 0, 0, that's the 1. This is sorted nums. Sorted nums 0. That's 0. This is 1. Oh, you're creating confusion, man. You're creating confusion. But that's what we do. N2 is here, N1 is here. So the base case, the DPI with 0. So like 1 level, right? 1 level with 0 is nothing. Okay, what is I? Max removal for nums1 indices 0 to j after I number of steps. So we say after 1 number of steps, if we're looking at 0, 1 number of steps, and we're looking at 0, which is basically just remove not just 1 step, it's I number of steps, right? So I number, so we just remove the whole thing. So which we say is n1, nums1 plus nums2 times I, okay? Okay, if this is good, we'll return immediately. Because we just keep going. And for j, so this will be good. This is not good. This is not nums1 j. This should be sorted nums j, right? And 1. This is sorted nums j 0. Okay, now let's give this a shot. Okay, is this right? Ooh, it was still not right. Holy crap. That is not what I had expected. Huh. Oh, I think this is not right. This is J. It's not supposed to be 0. What the okay. Interesting. I guess it is not right. Okay, we can debug this. This first we have to change. This is J, right? And this we're gonna do I think it's 1, 2, 3, 1, 2, 3, 4, 3. Okay, 2, 3. 1, 2, 3, and 4 and 3. All right, 1, 2, 3, 1, 2, 3, 4, 3. All right. Okay, here this one should be nums1, nums2, and we need x. This is minimum time. Nums1, nums2, x. We're gonna set a thing here. Okay, F5. Okay. DP is fine. Now I'm sorted nums is 1, 1, 2, 2, 3, 3. That's okay. Okay. And then we go. So S is 6. S2 is 6. So now 6 plus 6. Now it's going to be 12, right? S is 12. Then DPI 0 is I is 1. So we have one level. Right, at level 1, then it's going to be 3 plus 3 is 6, right? DPI, that should be no 6, that's 2. That's 2 because it's a 1 on 1, right? So it's 2. So we say we're gonna try to remove 2, right? Remove 2, and what we have S is 12. 12 remove 2 is no good. So I'm gonna just remove the JSON or remove it. Or remove it. Right? So now we have DPI is 1, J is 1, DP 1, 1, which means we do one step all the way to here. Well, one step all the way to here, we either don't remove this, so it's gonna be DP 0, 0. No, DP 1, 0, right? So either 2 or 1, 2, 1, 2, we remove this, so it should be removing 4, right? We're removing 4. So I think DPIJ should be 4. Yeah, DPIJ is 4. Then S is 12. 12 minus 4 is not enough. So we keep going. So the next is J is equal to 2. Right? J is equal to 2. So it's going to be 4. Or we're going to remove the 3, 3. So remove 6. Right? So it's going to be 6 plus, that's still 0 because we do one step, so still remove 6. 12 minus 6. It's still not enough. That's still bad. Done. Okay. Because we have to do 3 steps. Okay, so one step doesn't work. Alright, so now 2 steps. S becomes 18. Right? So 1, 2, 3, 1, 2, 3, 1, 2, 3. 18. So now we say, you know what? We might just draw it out first. I think it's important to draw it out first so we can compare the two, right? So this is I. We have 0, 1, 2, 3. And then this is 0. 0, 1, 2. We don't have 3. Right, this is 0, 1, 2. It's J. These are 0 because we perform 0 steps. We have nothing removed. So on here, this, because we have 1, 2, 3. It's nums 1. Nums 2 is also 1, 2, 3. So for one step, right, we do this, and I say all the way to here, the maximum remove is 2. All the way here, the maximum remove, so we either remove this, Then we should the maximum of this, which is 0. So that's 4. Right? Or we just remove it, and this is 6. Okay, so if we do 2 rounds, right? So we can remove this, so we can remove 3. Or we have here, we can remove this, yeah, which is a 6, and then we can remove one more here, which is this. So that should be 6 plus 2 should be 8, right? And here we can remove this, 9, and then we can remove this. 9 plus 1 is 13. Okay, last one, we'll do one more. So that's 4, right? Here we can remove, basically it's 8. 8 plus, right, we remove 8 plus this one, right? 11. Or we remove 12, 20. And then that's basically is 1, 2, 3, 4. 4 times 6, 24. So we shall be able to get it. What was the problem? I got 3. Oh, the problem is I only have, oh my god. Oh my god, I know what the problem is. The problem is this is need to be n plus 1. Need to be n plus 1. I thought that was the problem. I thought that was a problem. What the hell? N plus 1 doesn't work? Damn it. So let's try this. Okay, so 3 should be 3, 8, 13. 8. 13. Okay. Oh, shoot. I see the problem. Dang. Not only DP, but here. Dang it. Should be n plus 1. There we go. Or we remove it and then seek the max possible removal from dp I minus 1, j minus 1. Alright, we'll give it a shot. See if it works. Oh my god, it does not work. Interesting. A very simple test case. Let's build this. Take a look. So what we have is, okay, what we have is 8, 2, 3, 1, 4, 2. Expected 0. Oh, you did not consider the 0 situation. God, Lord. Sorry, yep, that is correct. So S equals this. You know what? I think this one should go first, right? S is equal to this. If S is smaller or equal to X, then we'll return 0. Then we do S2. Oh. Then we do X2. Yeah, edge case. Okay. Didn't realize. Yeah, try it again. Well, what should I say? It's from hint, right? It is basically from a hint. The hint tells me exactly how to solve this problem. All right, we have to redo this. Good problem, but we have to redo it. We need to create a copy of this, duplicate it, put it down somewhere, and then this I can move forward. All right, let's go back here. I'm gonna do this one again today. Yeah, I do this again, and yeah, so I can remove this problem. But we have to do today's challenge first. All right, even, odd tree. Have I done this before? Maybe I have. A binary tree is named even odd if it meets the following conditions. The root of the binary tree is at level index 0. Its children are at level index 1. Their children are at level index 2. For every even indexed 0, 2, right? Even indexed level, all nodes at the level have odd integer values. It's strictly wait, hold on. I need to read this again. So we have the levels, and then we say for every even index level, okay, all nodes at the level have odd integers in strictly increasing order. For every odd index level, all the nodes at the level have even integers in strictly decreasing order. Given the root of a binary tree, return true if the binary tree is even odd. Otherwise, return false. Oh, so it has to be even odd. Well, you have to do BFS. There's no other way. You have to do BFS, and then you have to keep track of the level. Oh, this is not hard. It's just meaningless, right? It's basically meaningless. And strictly increasing. I don't know. Do you know any way to do strictly increasing? So we have to check every single one on the level to see if it's that sounds stupid, very stupid. But you know, we just have to do it. There's no other way. You have to do it. You have to do, but it's okay because. Oh, yeah, I just realized something. I haven't set up the Java debugger yet. Damn it, that was bad. That was very bad. Okay, so we have to do it, and it will be easier to do it the other way, right? Okay, I don't care. I do not care. Right, I do not care. Or maybe you can. No, you cannot, because you need the level. Right, you need a level, so it's easier just to do it this way. We have a list of nodes, tree node, list of tree node. We got a queue, new array list. Oh, why you? Oh my goodness. Oh, what did I do? Yeah, this is not needed. Array. See, it doesn't give me. Yeah, I have to do this. Okay, and then we basically say while true. No, int level start with 0, right? We start into this 0, and how do we check if it's even or odd? Well, we can AND the two numbers. Yeah, you should AND the two numbers, because if you AND the two numbers, because it's the even level need to have odd numbers, and odd level need to have even numbers. That basically means that if you AND the level with a value, because it's going to be an odd level with even number or even level with odd number, so their AND has to be and then you AND with 1, right? It should be 1. If it's not right, then it will be a 0. Oh, what if it's a 1-on-1? Damn it. Exclusive OR. So level and the value exclusive OR. And exclusive OR has to be 1. The AND has to be 1. So exclusive OR and we AND with 1. So that's how I check. Okay, so this will be the same. We say while q dot is empty, right? And then we have to do a temp, unfortunately, but it's okay. And then because it's level 0, so we're just gonna go through. So we have to make sure if it's even and it has to be increasing, right? If it's even, it has to be increasing. Okay, so increasing. Is increasing. Okay, we have a Boolean value is increasing. Is inc should be true, right? Start with true, and then we basically say for tree node. It's a node of q, right? Then we say if, dude, we have to have something before. There's nothing in before. I don't have anything in before, so yeah, I cannot do this. Can't do it. Q dot size I plus plus. Right. If I is equal to 0 or this hold on. So I have to first check the parity. The parity is q dot get I is a node, right? Dot val value exclusive or level and 1. Okay, so if this is equal to 1, because if it's equal to 0, that means it's bad, right? If it's equal to 1 and we say I is equal to 0 or, right, I is equal to 0 or q dot get I dot val larger than q dot get I minus 1 dot val. So let's be increasing and is increasing, right? So I probably have to have another parentheses here, right? I don't think we can get avoided, right? So we have this. So if this and is increasing, so if it's increasing and increasing, that's good. Next round is increasing will be false, right? So this larger than this will be false. Oh, that could be equal, right? Oh Lord, so has to be, God, Lordy, we have to avoid that. Okay, so we can do and q dot get I dot val is not equal to q dot get I minus 1 dot val. Okay, so that shall be enough, I hope. So we have all this. That means we're good, right? This means we are good. So we're gonna check it. So if q.get, too many q.get. Let's say %s, right? We can say q, no, q.get I. We replace that with node. Ooh, that is not right. Hold on. I don't know why you have this. Should be just q.get I. Wait. Why only one of them gets selected? Right, you see the only some of the Q are selected. Some of it are not selected. I don't know why. Do you see that? That's weird. I have a Q here, but this one's not selected. Like, why? What the hell is this? Something is wrong. Comparing identical expressions. I have no idea what that means. Comparing identical expressions. Operator and is undefined. Huh? Ooh. Wait, how do I cancel? Okay. I might need another parentheses. I feel like that is the thing that we're missing. There we go. Alright, now I bet I can do it. I still cannot do it. Hold on, how do I save it first? And then %s q. I do not understand. I don't understand. How? How? How is it possible? That part of it was not selected. Like, what the hell? Is it because it's... I don't know. I do not understand. I do not understand at all. Like, yeah. I can find all of them, but if I do %s, I don't find it. This is as weird as it can be. Neofim. Grep missing line, something like that. I don't know. I don't know what was the problem. I mean, I guess it deserves some investigation. For example, if I do that, you know, it looks terrible, but I don't even know. Okay, so what if I do... Yep, now we get, I think... No, we still didn't get the second part. Alright, maybe I should do this. I think anything beyond is not taken into consideration. That's what I fear. Which means if I do %s, yep, but still, this Q is not getting picked up as well. And what the hell? What the actual hell is this? Right? It just doesn't make any sense. It is not. I pick up a Q. Okay, the while Q, and then this, and then 4, and here I have a Q. Like I'm supposed to have 2 Qs. They only select the first Q. Only match the first occurrence. Pattern match all. G. I think you need a G. I think you need a G. %s, right? Q. There we go. G. You need a G. Got it. All right, so that's good. It's an issue. It's a problem. I don't know how to solve it, but yeah, that was the reason. It was not global. It was an ugly, very ugly thing to write, honestly. Look at this abomination. But anyway, this is what we're gonna do. We're gonna say tree node equal to, and here's what we're gonna do: %s q.get I. We're gonna replace that with node, and we'll do g. There we go. All right, so tree node equal to q.get I. Right, and then we're gonna do this, and then we say if node.left, then temp.add node.left, and if node.right, okay, so blah blah blah. Once we're done, then we say q equal to temp as usual, and level plus plus, and is ink equal to not is ink. Right? So we handle everything, and then it's larger than this, and this, and these are not the same. Oh, wait, hold a second. I forgot the two more things. Oh, I guess it's fine because it's a Q get I minus 1, so yeah, we have to. Oh, we have an else. Right, else term false. It's any time that this does not work, then it'll be false. And then once we get out, now we return true. Okay. Oh. Okay, we'll run this. Alright, I'm dying to try either Go or Rust. I really want to try. Huh. All true. That was false. Alright, so what the hell happened? Level 0. Okay, level 0. We have the first one coming in. And tree node is just this one. Now the value is 5. Exclusive of 0 is 1. 1 exclusive of 1. So that is correct. And I equals 0. Okay, so I put left and right in it. Good. Now level 1 is increase should be not easy, which is false. Right, so 4 is good. The next one, right, so we got just 2. And then we say no dot vowel is 2. And level is 1. That was good. That was good. That's no. We say or, right, no dot vowel. Ooh, I think I know what happened. This and is sync. Oh, is ink. Oh, I see. I see what was wrong. All right. Yeah, let's just do it this way. Or, right, this equals 0 or I'm actually not sure. Maybe I can do this. If this or node of vowel is smaller than this and not as ink. So I have to really spell out every single thing. Are we missing? Yeah, I feel like we're missing the parentheses. So we add a parentheses. What? Yeah, it increases false, right? It increases false because we're like here. And I equals 0, that's false. Then we check this. So this is false, right? So this one is already false. And this is also false. Smaller, this is true, right? But this is false. So This is false, so this will be true, right? This will be true. And this will be false because this smaller than. Oh, no, 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 no. It sure depends on what this one is, right? Because if this is increasing, right? If this is increased, if this is true, then we have to be this is true. Right? If this is decreasing, which means this is false, then wait, how? We just like this. The current one shall be. Oh, this is correct. This is decreasing. It's the last one. It's the last one. Because. But still, how's the last one? How is this one still? Oh. Alright, so we make this and this thing. Well, we can also and, I would say node. All this. Yeah, that would be false here and false here. But how come we didn't? Because that's a 3, right? That's a 3. So that would be false. That would be false. So everybody will be false. So it should be false. How? How did we not get this one right? That's such an easy problem. What the hell? Right, this is good. We check this equal to 1 and we check this. Right, it's this or this or this. I don't get it. I don't get it. I don't get it. I don't even know what to test. I don't understand it at all. It doesn't make any sense. Oh, I forgot to put an initial value in it. My God. My God. That was stupid. That was as stupid as it can get. Jesus. Alright, now we're gonna explore other options. Now, I don't have other options because it'll be smaller. You have to treat it this way. There's no other way. You have to treat it this way. 0, the larger is increasing, or smaller is not increasing. So you have to do the 3 kind of checks on the condition. Yeah, there's no other way. We can try some test cases, but I feel like this one is easy enough. This one's easy enough. 1609 BFS. That is a good test case. And that will be a good test case as well. Try them all out. Reap benefits. Not. What the fuck? Oh. What? Okay. All right. This is incredible that you cannot get this right. This is absolutely incredible. What the hell? Which one? Which one violates, man? Which one? It's like, seriously, which one violates? Alright, let's see which one is the culprit. 10. 10? Is 10 exclusive or 1? Isn't 10 exclusive or 1? Okay, yeah, I just try this. Oh, wait, what? Huh? No. No. You're kidding me. Wow. I did not know. Wait. Is that true? Come on, Java operator precedence. You gotta be kidding me. Precedence. Wait, how do I read this table? Postfix. So from top to bottom is the precedence. Okay, so this is higher, and then this, and this shift, relational. Yeah, so relational is higher. Bitwise AND is higher than bitwise exclusive OR. Jeez, I did not know. I thought they are the same. Okay, alright, fair enough. So I have to add another. Oh my god, the readability is absolutely bonkers. Alright, I'm not gonna do it this way. The readability is way too bad. Way too bad. Alright, I'm gonna make some change to the code. That was terrible readability. Alright, so I'm not gonna do this. I'm gonna just set up like extra good parity. Okay. Is parity good? Parity. Yeah. Parity good. Good parity. Parity good. Okay, let's just say parity okay. Okay, parity okay is no dot vowel, exclusive or level, and then and one, this has to be, I think equal has a higher precedence, right? Equal has a higher precedence, so you have to put another parentheses on top of this. This is getting out of hand, man. This is getting out of hand. Right, so that's that. And now we have a Boolean, we shouldn't call it increase good. We should just call it trend okay. So basically for trend okay, we'll do all the way this. Okay, so that's trend okay. Right, that's pretty easy to read. So now here we are gonna just say if parity okay and this equal to 0 or trend okay. Look, now it's way more readable. All right, interesting. Yeah, interesting. Didn't expect. Didn't expect it to be this way. Oh gosh. Oh gosh. It's all right. Something like that. Because 0, 0 equal to has a high precedence. I couldn't believe this took so long. All right, it just took so long. Definitely not a difficult question. Yeah, but sometimes this type of thing happens and you just have to accept it. DFS. How'd you do DFS on this? Jesus, don't make it so hard on you. Just BFS it. It's easy, straightforward. You don't have to worry about it. Oh, it would just pop. It's all right. All right, that's it. I'm not gonna do this. I said I'm gonna do it, so I will do it. Okay, I said I'm gonna do it. I will do it, but I'm definitely not doing it just from scratch. I need to go with the previous solution. You ask why? Because I do not wish to reinvent a wheel. Right, the cheapest price, right? Yeah. So this is going to be Dijkstra. The key, right, for Dijkstra is to realize that we do not keep track of the price, because keeping to the lowest price is not the priority here. The priority is to arrive at the destination with at most k steps. Right? This means anytime we go beyond k steps, we have to abandon the current path and try something else, right? With Dijkstra, right, with Dijkstra and without keeping track of the lowest price, we're able to say that each node we visit has the smallest price, right? Each node has the smallest price within the restraint of stops, right? We're in the restraint of stops. Thus, we simply run Dijkstra with k stops limit until the destination is reached. Okay, so we don't need this. That is not necessary. We do need this. We do need this. Okay, and what we just need to do is the Dijkstra. So to do Dijkstra, we need a priority queue. Okay, so the priority queue has to be an integer. Actually, we need two things, right? I think it's two things. We need a node, and we also need a price. So it's gonna be this. I would say queue new priority queue. We need, doesn't matter, I can do 10, and then we say A B as the comparator. Integer dot compare compare A1 B1, right? Then we can say each element of Q is node and price. Okay, so now with the priority queue, we can just say while, that was rough. So while queue is not empty, right? While queue is not empty, then what do? Queue is not empty, we will get something out. Oh, you also need, Lord, I need three things, right? I need node, I need price, and I need the number of steps. Okay, the number of stops, right? Okay, so we need to say q.add new int. Okay, so we have the start, source, price, and number of stops. Okay, so here we say int element equal to q.pop poll. Okay, dot poll. Node is element 0, price is element 1, and stops is element 2. Okay, so we pop this out, then we need to check it, right? We need to check it. Then we say if node is equal to destination, right? If node is equal to destination, we return price dot, right? If node is not, then we say if stops is equal to k, then we will continue, right? We already hit k stops. Actually, that's not true. That is not true, because I can have k stops and the next one we hit is correct, then we still do. It's when the next one is wrong. So this has to be +1, right? Or we can actually put it, make it more generic, right? If it's a larger or equal to k plus 1, then you know it's not gonna work. Otherwise, okay, then we can do the same procedure as before. So I'm gonna copy and paste this thing, which is this thing. So we're gonna copy and paste this part. Right. So now we say for that's fine. Child, edge cost, and you always add new. Okay, you always add new because it's okay. The poll will always give you the shortest distance so far, right? It will give you the short distance so far. So always add new, and this is just going to be price plus edge cost, and the stops plus 1, right? Because you go to the next one. You go to the next one. Every time you go to the next one, you have, you do one more stop, right? You do one more stop. And what the hell is this temp? I don't have temp. There's no temp. This is Q. Q will add more, blah, 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 add, and then it will go up. So yeah, that's about it. And what do we return -1 at the end if we haven't found anything? Yeah, we return -1. So let's delete all these. Okay. All right, let's see. This one, does it work? We have a bunch of test cases. Good. Lots of test cases. Oh, I forgot parentheses. Oh, hold a second. There's no this. That was Python. Just switching back and forth. Yeah, that's the one. That's the Dijkstra. The Dijkstra, just keep using Dijkstra. Don't even worry about getting the. Don't even worry about getting the price. There's no need to worry about the price. Oh, I was just going to say, it doesn't feel right. Oh, I know what I didn't do right. Oh, yep. I know. I remembered. Damn it. Actually, this is not true, right? So we say without keeping track of the lowest price. Okay. However, right? There's a however. We must keep track of the number of stops a node. Number of stops to reach a node. And if a node has been reached before with the same number of stops as now, there is no need to visit it again because earlier visits always indicate lower price. So that's the thing we're missing. We didn't do, which is the stops. Okay, then how do we do the stops? Well, we have n nodes, right? So we can say int stops, right? Do we keep the minimum stops? Like when I hit this node, right, I have a certain number of stops, and if I go again, which I have fewer stops, and what if I do it again and I have more stops? So you either have fewer stops or you have more stops, right? That's the only case that we will do. Do you want to do a more stop version? Well, a more stop version, yeah, because if a smaller stop version does not work, a more stop version will not work either. So I have to, if a node has been reached before, keep track number of stops before with the same number of stops or smaller, same number or the same or smaller, right? Or smaller number of stops as now, right? There's no need to visit again because early visits always indicate lower price. Yeah, so if the previous you can reach it with smaller steps, right? With smaller number of steps. Now you have to do it with larger number of steps. And then if the smaller number of steps doesn't work, why would the larger number of steps work, right? So that's, yeah. Because it's always indicate lower price. And if lower number of stops doesn't work, why would larger number of stops work, right? So based on this, so we can just say this will call the min stops, right? New int, we can call it n, and I need to fill it, right? I need to say arrays.fill min stops with, I don't know, it doesn't matter how many stops, but at most we can do n+1, right? This is at most. And then as we go, min stops source, right? That becomes 0. And then we go blah 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 blah, right? And then we say if notice this, we're done. If stops is larger than k-1, or stops is larger or equal to min stops node, right? Then min stops node shall equal to stops. Okay, let's see how this one go. We added the condition. Okay, we added the condition to prevent infinite loop, but then we are wrong. Okay, all right, so we just need to figure out what happens. Oh, because the first, I shouldn't do it this way. Yeah, don't do it. We let it handle the first one. There we go. That was good. Hey, how are you? All right, this one should be right. Come on, give me some. There we go. There we go. So Dijkstra is not as easy as you thought, huh? So what's the runtime for Dijkstra? Well, we have to run on times to get this. We have to run at least on. So I call it on log n for Dijkstra. All right, on log n. Actually, it's I'm good. How are you? Actually, this is maybe a little bit more complicated because I have the repeats, right? Have the repeats, so the same node can be visited multiple times. Edges, it's the edges. Each edge shall only be visited once, right? I think each edge is visited only once. If each edge is visited once, because if you visit again, right, there's no point to visit the same edge again. So initially we Dijkstra it, go to the end, and then if it doesn't work, I try another thing, right? I try another thing, and eventually, so I will call this, okay, I'll call this OM. How about OM log n, where m is number of edges n is the number of nodes. Okay, that's how I think about this. Okay, so all right, I can turn this off. All right. I don't want to do another one. Yeah, I want to call it a day now. So today the biggest discovery is this thing. This is the biggest discovery today. I did not know that the AND bitwise has higher precedence over the exclusive OR. That one took me so long. Right, it took so long to debug this thing. Is this true for all the languages? It's a good question. I don't know. Precedence. Okay. Yeah, I think it's the same. AND is higher than exclusive OR, is higher than OR. But this is different. I think in Java, relation has higher precedence than these. See, that does not make any sense. I would prefer Python's way, where relations has lower than all these operations. But hey, what do I know? And the Walrus has the lowest. I got bitten here a couple of times as well. So if you do Walrus, you have to really apply parentheses very liberally. You have to use and basically use as much parentheses as possible. The Walrus operator. I only know one use case of Walrus operator. You know, it's just wait. I think Walrus operator is you evaluate, and then you assign, and you return the value in one shot. That's Walrus. So usually, like in if-else conditions, you can use Walrus. But it's more of a syntax sugar. All right, that is about it. I will end it today, and I'll see you guys tomorrow. Adios.